Welcome dear students. In this lecture we are going to talk about the types of the organic reactions. There are four major types of the organic reactions. First, substitution reactions. Second are the addition reactions. Third, elimination reactions. And fourth are the rearrangement reactions. So now let us discuss them one by one. Substitution reactions are also called as the replacement reactions, in which an atom or group of atoms directly attached to carbon atom of the substrate molecule is replaced by some other atom or the group of atoms. For example, if we have a molecule of ethyl bromide, it is treated with aqueous sodium hydroxide. Now what happens? This one is an atom which is directly attached to carbon of the substrate molecule. Here the substrate molecule is the ethyl bromide, and this one is the atom which is directly attached to the carbon atom of the substrate molecule. It will be replaced by this OH group. So here this atom which is directly attached to carbon of the substrate molecule will be replaced by this group of atoms, and that reaction will be called as the replacement or substitution reaction, and the product will be CH3 H H OH. The major product will be ethyl alcohol, also called as the ethanol, and here the side product will be NaBr. These sodium and bromide, they will form NaBr. It will be a side product here. So this type of reaction, that is the substitution reactions. Now the substitution reactions may be electrophilic substitution if an electrophile attacks, or nucleophilic substitution if a nucleophile attacks. Electrophilic substitution reactions are usually shown by alkanes, terminal alkynes when they show their acidic property, and benzene. Similarly, the electrophilic substitution reactions are also shown by the carboxylic acids when they show their acidic nature, when their hydrogen is replaced by some other group. In the same way, the SN reactions, they are shown by alkyl halides. They are shown by carboxylic acids when their OH group is replaced by some other groups. And the electrophilic substitution reactions, my dear students, they are also shown by the alcohols. In those reactions in which their H is replaced by some other group, and SN reaction are also shown by the alcohols in which the OH group is replaced by some other group. So these are the major classes that show the electrophilic substitution and nucleophilic substitution reactions. Now the next one are the addition reactions. They are very simple reactions. They are just shown by the unsaturated compounds having multiple bonds. For example, if we have ethene molecule, and this ethene molecule is brominated in the presence of solvent carbon tetrachloride. My dear students, in that case, there are two bromine atoms. One bromine atom will get attached to this carbon, the other bromine atom will get attached to this carbon atom. The product form will be CH2, single bond CH2, Br and Br. This is 1,2-dibromoethane. Now, my dear students, in this reaction, there is loss of one pi bond. You can see that here the double bond was there. One bond is the sigma, other is the pi bond. So pi bond has lost, and now the formation of two new sigma bonds has taken place. So these two new sigma bonds are formed. So formation of two sigma bonds. So addition reactions are those reactions in which some reagent is added to an unsaturated molecule, which results in the loss of one pi bond and formation of two sigma bonds, and the unsaturation is changed to the saturation. These reactions are shown by all those organic compounds that have multiple bonds, like you can say alkenes, alkynes, then benzene and aromatic compounds. They also show the addition reactions, but they are reluctant to show the addition reactions. And then aldehydes and ketones, they have multiple bond between carbon and oxygen. They also show the addition reactions. Next one are the elimination reactions. But before discussing elimination reaction, let us see another example of the addition reaction of the aldehyde and ketone, in which HCN is being added in the presence of a base. Again, the hydrogen will move to oxygen and CN will move to carbon. COH, and here CN will be attached. Again, you can see one pi bond is lost and the formation of two new sigma bonds between carbon and CN and one between oxygen and hydrogen. So they are the addition reactions. They may be the nucleophilic addition reaction or electrophilic addition reaction depending upon the type of the reagents that is attacking. Alkenes and alkynes, they show electrophilic addition reactions. The aldehydes and ketones, they show nucleophilic addition reactions. Now next are the elimination reactions. Elimination reactions are exact reverse of the addition reactions. In elimination reactions, there is loss of two sigma bonds and you will see formation of one pi bond. And because sigma bonds are lost and pi bonds are formed, it means the saturation will be changed to unsaturation. For example, if we have 1,2 dibromoethane and that is treated with zinc dust. Now what happens? The zinc attaches both bromine atoms. You will get zinc bromide plus a pi bond will be formed between two carbon atoms and ethene will be generated. So these are the elimination reactions in which the saturation is changed to unsaturation and at the loss of two sigma bonds. These are the two sigma bonds which are lost and this one is a pi bond which is formed. These are the elimination reactions. And elimination reactions, my dear students, they are also shown by the different organic compounds. Like, just like I will like to give a concept here, that if we have again ethyl bromide and it is treated with NaOH, but this NaOH is not dissolved in water, rather it is dissolved in ethanol. It is alcoholic NaOH. Now we have changed the condition. Instead of making it react with the aqueous NaOH, now it is reacting with the alcoholic NaOH. So my dear students, the nature of products will be changed. This OH will join with one of the hydrogens of this carbon. You will get water plus this sodium will be joined to this bromine. You will get sodium bromide in ionic form, Na positive plus Br negative, because when the sodium bromide will be in water, that will be ionized. Now, sorry, my dear students, here this hydrogen is not taken, rather it's a small mistake here. The hydrogen from beta carbon is taken. The carbon to which functional group is attached, this is the alpha carbon. Bromine is the functional group, this is the alpha carbon. And the carbon which is directly attached to alpha carbon, this is the beta carbon. So hydrogen will be taken from beta carbon and that will join with OH to form water. and alpha carbon will give functional group and it will form sodium bromide. And now double bond is formed between two carbon atoms and you will get ethene. So just look at this, that by changing the conditions, the products they are also changed. When you treat the alkyl halides with aqueous NH, that is the substitution reaction. But when you treat the alkyl halides with the alcoholic NH, then you get the elimination reactions. And with the name of all elimination reactions, you will see the prefix D, like dehydration, dehydrohalogenation, dehalogenation. So all those reactions having De at the start of their name, they will be basically the elimination reactions. And last are the rearrangement reactions. As the name itself indicates, that in these reactions there will be just rearrangement of some groups, just like tautomerism is also an example of the rearrangement reaction. And here we will be talking about this example. That is basically an ketoxime. Now, my dear students, the rearrangement takes place, and usually at the top of the arrow, we will show the sign of the rearrangement. Now, after rearrangement, you will get CH3, NH, O, CH2, and CH3. So this product is produced, which is basically an amide. And now, my dear students, in this case, you can see that this nitrogen along with this hydrogen, it has rearranged itself and it moves here. And this oxygen forms double bond with the carbon and the ketoxime is changed to the amide. Similarly, the tautomeric reactions in which the keto form is changed to enol form or enol form is changed to keto form and the amino acids are changed to zwitterine, they are all examples of the rearrangement reactions. So my dear students, these are the four major types of the organic reactions that you are going to study in the different chapters of the organic chemistry. Next time we will come up with some new lecture. Till then, take care.